In this video, we're going to talk about the start of section 1.2, in particular, qualitative and quantitative data, and what that means in terms of statistics. So qualitative data, I'm going to go ahead and give you the definition. And I'm going to be lazy and use DEF to represent definition. This is data that is the result of categorizing or describing attributes. That is the result of categorizing or describing attributes. In a previous video, I called this categorical data. That's another way of saying it. It's categorical data. An example would be hair color. All right, so you could answer, black, brown, red, blonde, okay? Or there could also be other answers. Gray would be another one, or light brown, depending on how exciting you want to get. But hair color would qualify as this because it's non-numerical. Another example would be blood type. Blood type. That would be an example of this type of information. Now, here's what's interesting, and I want to make a note of this. When we're looking at categorical data, all we can really do is summarize what we're seeing in terms of the largest amount of data and percentages. And really, that's it. That's really the only summaries we can give. So summaries will include largest amount of data or smallest, whatever you're interested in, categories, and maybe percentages or proportions or something along those lines. But that's about it. It's really all we can do for qualitative data. For quantitative data, that's a little bit more exciting. So this is numerical data here, and the formal definition is data that is the result of counting or measuring attributes. I like that. Data that is the result of counting or measuring attributes. I just realized attributes is spelled with 2 T's. And, I did it up there. Okay, good job. All right, so an example for this one would be money. You count money, all right? But it also means that you could be looking at something that has a decimal, because money can be decimal, especially when you're including things like percentages for maybe it's sitting in a bank and earning some interest or something. Okay, so money could potentially be counted, but it also could kind of be measured based on percentages of growth. Okay, another example could be the number of texts you receive in a day. Wow, in a day. Okay. That's another example. Now that wouldn't have decimals attached. Those would be whole numbers. All right. And as I kind of just brought that up, there's really 2 types of quantitative data. There is what's called discrete data and continuous data. So discrete is the result of counting. And what that really means is there's no decimals. So when you count the number of texts you receive, you don't get a half a text, okay? It's a text or it's not. Continuous, that allows for decimals, continuous data, okay? So this is data that's measured. But just for our sake, it will include decimals. So weight would count as data that's measured because you could have 0.4 pounds of something. All right. So continuous versus discrete. And then because it's numerical, we have a hell of a lot more options. Summaries are going to be off the charts for quantitative data. Okay, so here, let's look at an example. We'll do some classifying here. You go to the supermarket and you purchase 3 cans of soup. They listed them for you. 2 packages of nuts, 4 different kinds of vegetables, which they also listed both of those. 2 desserts, and they did include ounces on some of these. Let's name the data that is quantitative, discrete, quantitative, continuous, and qualitative. So basically, we're kind of doing qualitative and quantitative. And then for the quantitative, is it discrete or is it continuous? Okay, so basically, let's start with the quantitative discrete. These are items that are numerical but counted only. Okay, so only counted. So those would be the amounts you got of each product, right? So for quantitative discrete, here I'm going to abbreviate that. Okay, quantitative discrete. That would be the 3 cans of soup, the 2 packages of nuts, the 4 kinds of veggies, and 2 desserts. All right, so that's quantitative discrete. For quantitative continuous, now we're talking about things where decimals could be allowed. And really, the first thing I'm going to go to are those ounces because those ounces are representing weights, and weights could be decimals. In fact, you can see decimal ounces. We do for the lentils. See here in the lentils, it's 14.1 ounces. So decimals are allowed when you're talking about ounces. That's not uncommon. Therefore, those will all be continuous and quantitative. Okay, so that would be the weights of soup, in particular, the 19 ounces, 14.1 ounces, and 19 ounces. And it also works for the weights for desserts. So those desserts are 16 ounces and 32 ounces. Okay, so the qualitative data we're talking about here is all of the categories, okay? So the fact that we have the types of soups, nuts, vegetables, and desserts, those are all qualitative. So I'm just going to go ahead and state it just like that, all the types. So the types of soup, nuts, veggies, and desserts. Those all are the categories that they fall into. Okay, so let's look at this next one. We're going to determine if the data is quantitative or qualitative. And then if it is quantitative, whether it's continuous or discrete. Okay, so the number of pairs of shoes you own. So this would be a counting thing. So that's quantitative. And it would be discrete because well, I guess if your dog ate half of your shoe, maybe you could say it's partially disappeared, but nobody sells half shoes or anything like that. So quantitative, discrete. All right. Type of car you drive. All right, that will be qualitative. We're talking about a category. Distance from your home, that can include decimals. So that's quantitative and it's continuous. Number of classes you take in a school year, that would be numerical and that's quantitative. And again, you don't take half a class, so that's discrete. Decimals don't make sense in that case. Type of calculator you use, that would be qualitative because now they're talking about graphing calculators, scientific calculators, basic calculators. I just realized I spelled that wrong. Let me fix that. Qualitative. There we go. Weights of sumo wrestlers. Okay, we've talked about weights. Weights can have decimals, so that's quantitative and continuous. Number of correct answers on a quiz. So the correct answers, the amount of correct answers, that has to be um, quantitative and discrete, because we're not talking about things being half correct. So you might get half points, all right, but that's not making the whole problem correct. If you miss points, that means it's no longer correct. So this will be discrete. And then IQ scores. Well, this they kind of mentioned in this one that it could be up to some debate. I like that, up to some debate. It is quantitative. Most people would categorize it as quantitative. I'm going to go ahead and go with discrete personally. I kind of feel that when we report an IQ score, we report it as a whole number. But I know why they're saying there could be some cause for discussion. And if you feel very passionately that I'm wrong about that, you can most certainly send me an email and I'd be happy to allow you to have your voice be heard.